In this video, we discuss about the friction between the gear teeth. Friction between that gear teeth. So here we calculate the maximum work done. Maximum work done. So to calculate that maximum work done, we have to find out the work done. We have to find out the work done that we observe in the while engaging the two tooths. While engaging two tooths in their contact, while engaging the two tooths when the two gears are in contact. So to find out the maximum work done, we must find out the work done. We must find out the frictional work done, total frictional work done during contact of that gear. So the frictional work. So work formula is nothing but a force into distance. So how we can calculate that work? So work we can find out by force into distance. So that frictional force we have that formula. Now this distance we can calculate by using that velocity formula. So velocity is nothing but distance upon time. So we have to eliminate this time. So multiply with time value. So we will get distance term, and with force into distance we will get the work done. So here this formula is given. Frictional work done. So we calculate frictional work done during races and during approach condition, and then we add these two terms. We get total frictional work done. And then we find out the total frictional work done and maximum work done by considering this total frictional work done. So frictional work done is nothing force into velocity. This term related to the force. This term related to the frictional force. So this frictional force into distance. This distance is nothing but a velocity into time. Velocity into time, it will give distance. So this will calculate during races, and this will again calculate during approach condition. Both work done are added to each other. We will get total frictional work done, and from the total frictional work done, we have to find out the maximum work done. By differentiating this total frictional work done with respect to the total path of action, path of that action, and then we can find out the maximum work done. So here these two gears are given. With center O1 and O2. With some radius R1, R2. Pressure angle in between this gear. Pressure angle in between these two gears are the phi. Pressure angle is also given as a phi. And here that some triangles are constructed. So these triangles are, here we consider O2AP, and some one triangle is a O2BS. So two triangles here considered, this O2AP and O2BS. These are similar triangles. And for the similar triangle we can write this as a O2A is equal to O2B. For the similar triangle we can write as a O2A is equal to O2B. So from this triangle, this is the one side, O2A, and from this triangle, this is the one side, O2B. So these are similar. As these triangles are similar, these are also equal. So we consider this. Again, O2P is equal to O2S. O2P is equal to O2S. This side and this side are equal. This side and this side is equal. Again, this angle O2AP and O2BS are 90 degree. O2AP and O2BS, these are the angles are the 90 degree. These angles are the 90 degree. So by considering these two triangles, we can write like this. And also we can write this AP is equal to BS. We can write as a AP is equal to BS. This side and this side is equal. We consider this side and this side equal. So now this AR, now AR value, now this AR value we can write as a arc AE, AR value, A into R, A to R, A to R value, A to R, this is nothing but the AE, this is nothing but this AR value is nothing but this arc AE, this AR length is nothing but the arc AE, so we consider this AR is equal to arc AE, and here it is a capital BS, this indicate length BS, this indicate length BS is equal to arc BE, BS is equal to arc BE. So we consider this is a arc, and with this consideration we can consider this AR is equal to AE, AR is equal to AE, and BS is equal to BE, So with this consideration again, arc AE minus arc BE is equal to arc AE minus arc BE is equal to, now this arc AE nothing but a AR, arc AE nothing but a AR, and arc BE nothing but a BS. So we put arc AE and arc BE subtraction as a AR minus BS, Now arc AB is equal to RP, Now here consideration of the arc AB is equal to RP. This RP we consider is equal to the arc AB. We consider arc AB, and this is nothing but a path of recess. Now velocity of sliding in this formula, while calculating work done, we have to consider that average velocity, and this velocity of sliding is considered as a omega 1 plus omega 2 into distance between each point and the point of contact, distance between this point P and point of contact. So this maximum velocity of sliding during these races, we can consider as a omega 1 plus omega 2 RP, So average velocity is nothing but divided by 2. Average velocity considered divided by 2. So this average velocity considered as divided by 2, and this we consider here. So this velocity of this average velocity considered as a divided by 2. Now RP, this RP value we can put as a O2A theta 2. This RP is nothing but a arc. This RP we consider as a AB. RP length is considered as equal to the arc length AB. So arc we can calculate it as a radius into angle occupied by that arc. Since this RP length we equate to the AB, and this arc AB we can calculate it as a radius of that particular arc, and the angle subtended by this arc, is theta 2. So and radius is R2. So arc AB is equal to R2 into theta 2. So this will be put here. Arc O2A. Now this radius we consider as a O2A. This radius we consider as a O2A. And for this O2A, this O2A is somewhat different. It is not considered not equal to the R2. This O2A is somewhat different. So this O2A we can calculate by considering triangle. This triangle O2AP. By considering this triangle O2AP, and with this consideration we can write as a R2 into cos phi. With that consideration we can write as a R2 into cos phi. So for O2A we can write as a R2 into cos phi. So this R2 is a pitch circle radius. And O2A is not similar to that R2. This O2 is somewhat different from that pitch circle radius R2. So with this we can now move further. Now here frictional work done is equal to this frictional force mu by divided by cos phi into average velocity. That average velocity we calculated. Previously, that average velocity we calculated here. This average velocity we calculated here. This value put here, and with this time. Now time we can calculate it as a omega 2 is nothing but a radian per second, and theta 2 have unit radian. So radian get cancelled, and that second in the numerator comes into upward into the second in denominator comes into upward in the numerator, and this you will give time. So theta 2 unit is a radian, omega 2 unit is a radian per second. So radian get cancelled. Second in denominator comes in the numerator, so it will give time value. So this theta 2 divided by omega 2 is time value. Theta 2 divided by omega 2 is time value. Average velocity term we calculate, we consider from the previous one. We consider from the previous one, and with this we move further. And then this F by cos pi is a normal force at point of contact. F by cos pi is a normal force. And now after simplification we will get, after simplification of this all term, you will get this as a 1/2 into 1 plus omega 1 by omega 2 r2 theta 2 bracket square mu f, r2 theta 2 bracket square mu f. Here I forgot to write a mu. Here I forgot to write mu value. Mu f value I forgot to write here. So with this, when you put mu f here and by take omega 2 inside of this bracket, so omega 1 by omega 2 plus 1. So here write 1 plus omega 1 by omega 2. This half as it is, that half as it is remaining here. I forgot here mu f value, and r2 into theta 2 square, r2 into theta 2 square. So this we can write here, and this we can consider as a normal force. F by cos pi consider as a normal force, and we can write EF value here. So with this this cos phi and this cos pi, I forgot to write this term in mu f by cos pi. So this cos pi and this cos pi get cancelled. Mu f term remain as it is. This r2 and theta 2 square, here appear like here. This omega 2 move into this bracket. So omega 1 by omega 2 here. Omega 2 by omega 2 1, it comes here. This 2 as it is 2 here. So this after simplification it will become like this. And this will be written for the races. Similarly, approach also there. There are two part. Approach part and races part. We write here for races part. Similarly, we can write for the approach part. But approach part, this are two changes. This r1 and this radiation theta changes for approach part. This radiation theta for this approach part now becomes as a r1 and theta 1. So similarly, we can write for the approach part. Only changes is that here this radiation theta changes. So we can write as a r1 and theta 1. And total now total work done is a addition of both. For this approach part and for this races part. So we add these two terms. And we will get this equation. So addition of two parts, approach part and a races part, we will get this equation. Again simplification of this, we will get this equation. This is final equation. And in this final equation, we will write in this final equation this r1 omega 1 and r2 omega 2 are considered equal. R1 omega and R2 omega 2 are considered equal because this product remains same. So we will get, after simplification of this and by considering R1 omega is equal to R2 omega 2, this equation. Now in this equation, if you look at this term, first term, R1 and R2 doesn't changes. When you select the two gears, this R1 R2 doesn't changes. Frictional value is also not changes. This force is also not changes. So this term will remain same. This is considered as a constant. This term is considered as a constant K. And for these two terms R1 theta 1 and R2 theta 2, we write this as a r2 theta 2 is equal to L2 and r1 theta 1 is equal to L1. R1 theta 1 is equal to L1. So we put this value here. We put this value here. We put this value here. So here this square is outside of this bracket. This square is also outside of this bracket. R1 theta 1 total term square. R2 theta 2 total term square. It is not a theta 1 square, but it is a R1 theta 1 bracket square. R2 theta 2 bracket square. So with this and when we put R1 theta 1 is equal to L1, R2 theta 2 to L2. So this becomes as a L1 square and this becomes as a R2 theta 2 L2. So it becomes L1 square and L2 square. Now after simplification we will get this equation k into L1 square plus L minus L1 bracket square. L minus L1 again it is L minus L1 total bracket square. Now with this this is the total work done. This is total work done against friction. This is total work done against friction. So to find out maximum work done, we have to differentiate this term. And equate to 0. Differentiate this term with respect to L1 and then equate to 0. So we differentiate this term with respect to L1 and then equate to 0. We will get this equation. Now in this equation 0 is equal to this term 4L1 minus 2L. 0 is equal to 4L1 minus 2L, and after simplification we can write as a L1 is equal to L by 2. So work wasted in this friction will be least when arc of approach and arc of races are equal. When arc of approach and arc of races are equal, then we can say that work wasted in that friction will be minimum. So this is the derivation for friction between the gear teeth. So to find out this friction between gear teeth, we have to find out work done. So to find out the work done, there is formula force into distance. So frictional force formula we have mu by cos phi. We have that formula mu by cos phi, and this distance we can calculate as a velocity into time value. So this velocity we can find out by sliding velocity. We consider as a sliding velocity, and we consider here average velocity, and then we move further. Then we find out the work done during races part, find out the work done during approach part. Then add these two parts, approach part and races part. We will get total frictional work done, and then we simplify this. And we will get some equation in terms of the L, in terms of the length, and then we differentiate with respect to this particular length equate to 0. We will get a maximum work done condition. As a L1 is equal to L by 2. Now from this we can say that with minimum frictional work between this engaging gear when this arc of approach is equal to arc of races. So we will get this condition. In this friction between these gear teeth. So we go through some numericals. In this on this particular part and previous part, and then we conclude this particular point. So we go through one numerical. A pair of spur gear with involved teeth is to give a gear ratio. So gear ratio is given 4:1. The arc of approach is not to be less than the circular pitch. And the smallest wheel is the driver. The pressure angle is given as a 14.5 degree. And asked to determine the least number of teeth that can be used on the each wheel, the addendum of the wheel in terms of the circular pitch. So here to find out the least number of teeth on the each wheel, we have some formula, and with this formula we have to move further. So to find out the least number of teeth that can be used on the each wheel, we have this formula. So before this we have to this maximum length of the path of approach. We have this formula for maximum length of path of approach is equal to r sin phi, and this maximum length of arc of approach. So path of approach is formula is r sin phi. Arc of approach, as soon as this arc of approach considered, we divide this path of approach by cos phi. Divided by this path of approach by cos phi. So the sin phi cos phi becomes as a tan phi. So it becomes arc of approach becomes now as a r tan phi. And this we can equate as a circular pitch PC, which is given in this data. So arc of approach not to be less than circular pitch, This is given in this particular numerical. So we equate this arc of approach is equal to circular pitch PC. And with this condition, now we move further, and then we can find out the t value. So now again this term equal to the circular pitch again we can find out as a pi m. So pi m again this for this m again I can write as a small r is equal to mt by 2. For this m again we can write as a 2r by t. So for m replaced by 2r by t. Now this according to this condition, r tan phi is equal to circular pitch now calculated as a pi into 2r by t, So t becomes as a is equal to pi into 2 into r, pi into 2 into r divided by this r tan phi, So r get cancelled, and we will get 2 pi divided by tan phi. So tan phi value, pressure angle is given 14.5 degree. So put this value, and after simplification we will get 25. So this is a small t. Capital T we can get as a by using this gear ratio 4 into t. Is equal to 4 into 25, 100. So smaller gear teeth as a 25, larger gear teeth as a 100. And the remaining term is a addendum of the wheel. In terms of the circular pitch. We have formula addendum of that wheel in terms of the circular pitch. We have formula like this. We have formula in terms of G, gear ratio G, and in terms of the pressure angle phi, and with this model value m. So in this formula we have in terms of m, G, and phi. So these values are given. So in this example, m value is not given. We put as it is m value. T value calculated 100 by 2. 1 plus gear ratio given as a 4. G value becomes as a 4 plus 2. Sin phi angle is given 14.5. Then after simplification we will get this value 0.8739 m in terms of m, and m is nothing but a PC by pi. So this we calculate in terms of the circular pitch. This value we calculate in terms of the circular pitch. So they asked to find out in terms of the circular pitch. So this m is converted into circular pitch by considering this PC is equal to pi m. Circular pitch is nothing but pi into m. So m is nothing but PC divided by pi, and this addendum of particular wheel now converted into in terms of the circular pitch. So here we find out frictional. In this video we find out the frictional work done while engaging in these two gears, and then we go through some numericals. So in the next video we go through some again 3-4 numericals, and then we move further.